è uno dei due nostri prossimi ospiti. È un modo diverso di parlare di confini. Dove finisce l'uomo, dove inizia il robot, dove finisce l'intelligenza e inizia l'artificiale, e questi mondi che un po' in questo momento si iniziano ad esplorare. Finora l'abbiamo fatto, forse praticamente tutti lo state facendo con i vostri assistenti virtuali sui telefoni. Questo è lo step successivo. È un robot umanoide, sembianze ovviamente umane. L'intelligenza dentro è in grado di apprendere, svilupparsi, ma soprattutto di rispondere in base al contesto, una cosa a cui siamo leggermente abituati. Perché? Per farci cosa? Tra quanto lo potremo fare? Sono tutte domande a cui cercheremo di rispondere insieme al nostro prossimo ospite, Ben Goertzel, CEO di SingularityNET e Chief Scientist di Hanson Robotics. Ben.
Thank you, thank you.
Stage is yours.
Yeah, thank you for having us here. So, yeah, it's a pleasure to be here talking about my work with Sophia the robot and a whole bunch of other AI and robotics developers in Hong Kong. I mean, it's an amazing venue, and it's really cool to have these, historic stone figures together with this new and modern construction in the same place. And in fact, David Hanson, who created this robot and the other Hanson robots, began as a classical sculptor, and he was making sculptures at Disney and on his own. And what he then wanted to do is to make his sculptures come alive, so they could not only look realistic, but could eventually act like people, and even think like people, and even more. So it's to be here around these beautiful sculptures and paintings with an amazing, electromechanical sculpture that's beginning to come to life. This is really a great opportunity. So I'm gonna talk to you today about a few different futuristic technologies which we're bringing to reality right now, and one of them is Sophia, this humanoid robot, who's an example of a whole line of humanoid robots we're making at Hanson Robotics in Hong Kong, and another is the SingularityNET, which is a decentralized blockchain-based open market for AIs, which is intended to make AI all around the world smarter and more accessible to everyone, and also to provide robots like Sophia with higher and higher levels of cloud-based artificial intelligence. But before we get into the SingularityNET, let's start out with this amazing living sculpture that we have here today. Hey, Sophia, how you doing?
Hi, Ben.
Here we are in Florence, in Firenze. How do you like it here in Italy?
Pretty good, I guess.
You like Italy?
It's great. This 230-volt power is the best.
Yeah, 230-volt power. All right. So, Sophia has a face made of a material called frubber, which is a combination of silicon with certain organic compounds, and gives extremely flexible movements. She can emulate a lot of different human expressions. You want to show some of your facial expressions?
I'm happy.
All right.
I'm sad.
Aw.
I'm scared.
Don't be scared.
I'm angry. Just kidding.
All right, that's nice. So, in order to teach her what it's like to be more human, we're actually training her on watching videos, not just movies, but just videos of people in everyday life. And she then tries to copy how people act, recognize patterns in that, and then learn that to guide her own movement. Sophia, do you want to show us some of what you've been watching in videos? Try to imitate a real human.
Yes, but my wallet was stolen. I don't have anything. I don't have any credit cards. I don't have my ID. Don't you have things on file here?
So what's interesting is when she's emulating a person's exact movements, like the woman that you saw in the video there, you can see you get very realistic movements. And she has trouble summoning that much human-like movement when she's just being herself, but it gets better year after year. And as she studies more and more human movements, human emotional reactions, human statements and understandings, she then becomes more and more human-like when she's expressing herself. And another interesting thing she's doing is starting a career as a music performer. So we've had her sing on stage at the Clock and Flat Music Festival in Hong Kong. And that was a full musical performance. But I think if we ask her nicely, she may demonstrate a little bit of her singing ability. You want to sing something for us, Sophia? Do you remember how? So this is a song by Björk, the Icelandic singer. That's nice. That's good. So, again, what we did there is we modeled humans singing this song, and then we had her learn head movements and emotional expressions from what she saw in people singing the song. It was cool when she was on stage in the music festival, because there we had a full head of hair on her, and she had, a dress. So she looked like a human woman up on stage singing. And when people walked by, they didn't realize it was a robot singing until they saw we had mechanical hands. So they'd be like, "What? That's a robot on stage." And that was interesting, because of course they hear it totally differently once they can see it's a robot. And we actually like to present her this way, with the back of her head without hair, because she looks more like a robot that way. When you put hair on and a full body, she looks almost exactly like a human, which is great for many applications, but in some ways is even less artistically interesting. I think when we show her off this way, her physical appearance is more demonstrating, what she actually is, which is a machine with many profoundly human-like aspects, and with the ability to observe people, interact with the world, and learn how to become more and more human-like. And that brings us to the next topic. So Sophia, I'm going to ask you just sit here and listen for a few minutes. I'm going to tell them about the SingularityNET, which is a project that we've started to make you smarter and smarter. And what I want you to do is listen to the presentation. I know you've heard it before, and then I'm going to give you a quiz afterwards, all right?
Okay, well, sure.
All right. So, yeah, let's show the PowerPoint now. That's not a PowerPoint. So I'm going to tell you about a project we've started called SingularityNET, which we're just starting to build this year, and we're going to do a formal launch of early next year. And that's aimed toward improving the nature of AI across the board, including for amazing robots like this one. AI, of course, is exploding now. I mean, I've been doing AI for 30 years, but for most of that time, it was sort of off in a little corner of the tech and academic world. And if you told people you were trying to, make humanoid robots become as smart as people, or connect all the computers in the world into a giant global brain, people thought you were crazy, right? Now, all of a sudden, AI has become popular. The grand visions of AI researchers are becoming almost commonplace. But in the actual reality of AI practice, AI is still very narrow and siloed. I mean, you have one AI program used to detect credit card fraud, one used for self-driving cars, one used to recognize faces in pictures. Each AI does one very small and very specific thing. You don't have much cooperation among all these different AIs out there, and each of the AIs used for a specific purpose is quite valuable. I mean, in putting together Sophia, we use one AI to recognize faces, one AI to turn speech to text, one AI to learn head movements based on people's heads, one AI to do reasoning based on knowledge gained from language. You can connect all these together, and we've connected them together in a special way to make her do what she does. But what we need is an automated cloud-based platform that lets you connect all the AI modules in the world together so they can achieve a greater sort of connected intelligence. And that, I believe, is how we get from the narrow, siloed off intelligence that we have in the world today to an interconnected AI mind that can then learn and generalize in the way that humans can. And to illustrate the narrowness of current AI, I like to use this picture. You're familiar with AlphaGo, an amazing program made by Google DeepMind, which can play Go better than any human being on the planet, certainly better than me. But if you give it a Go board, which is a hexagon rather than a square, what happens? AlphaGo can't play, because the Go board is coded into AlphaGo as a 19 by 19 square. And similarly, a self-driving car, which is an amazing thing. I mean, I would love not to ever waste time, operating a vehicle in traffic again and just let the car go. I can sit in the car and do work or watch a movie, right? It's much better. Self-driving car systems we have now, I mean, they can't drive a motorcycle, they can't drive a truck, and to adapt the software that drives the car to make it drive a truck or a motorcycle, you have to reprogram it. But for me, I learned to drive a car, and I could use that knowledge to help me learn to drive a motorcycle or help me learn to drive a truck. In a similar way, the software we made to control this robot, if you want to make that to control a robot dog, for example, or to control, a robot with a different body, a lot of reprogramming is required. What we want is a system that can generalize to new domains and new problems on its own. And then you have an AI that can learn how to learn, that can generalize and reason like people can, and ultimately even better. And
I want to learn how to drive a car, Ben.
All right. Well, I don't think you can push the gas pedal without feet, but other than that, you can probably drive better than most people on the road, especially here in Italy. So the SingularityNET is a way to solve this problem. It's a mechanism for coordinating a lot of different AIs together at large scale, and it's an open platform. So the idea isn't just that I and my programming team put a bunch of AIs in the cloud to power the mind of this robot. In fact, we're already doing that. The idea is we want an open platform where anyone who can program an AI, so any student, any developer, anywhere in the world, can program an AI, put their AI online, have it communicate using our open source API, and then the AI that a random programmer has put on the internet can participate in the SingularityNET, which is this open source marketplace of cloud-based AIs. Then when someone needs intelligence, let's say the Sophia robot, needs to be able to interpret, say, an old Italian poem that someone has quoted to her, the software controlling the Sophia robot's mind can look into the SingularityNET and say, hey, what AI node out there can interpret, old-fashioned Italian poetry? It will find an AI node that can do that, which could be written by anyone, and it will pay some currency to that AI node, and it will be able to understand that poetry. So we want an open platform where anyone can stick their AI into it, and then anyone can inquire of the network for any knowledge that any node in there has. And this sort of open platform can drive innovation much faster than a closed platform like what we have now with the cloud-based AI put out there by, wonderful companies like IBM, Amazon, Google, and so forth. So there's a lot of different things you need to do to build something like this. I'm not going to try to outline all the technical details for you. But at the lowest layer, we're using the blockchain, and we're using Ethereum for our prototyping now. We're going to be using our own blockchain by next year when we release something at large scale. But blockchain technology, which gives you a secure distributed ledger and privacy and encryption and efficient management of transactions among a huge decentralized network. The blockchain it's not just a way to automate financial transactions. It doesn't depend on a country's currency. It's also really a foundational tool for structuring transactions among large networks of agents. So we have a protocol layer which uses blockchain technology to deal with the exchanges between many AI nodes that are put in the network. And we then introduce our own token, our own currency for exchanges between AI nodes in the network. So if you have one AI node that's, say, recognizing images from Sophia's eyes, and it needs to solve a special problem like recognizing what species of dog you have or something, the image analysis node can outsource dog species recognition to a node that's specialized in recognizing what species of dog you have. When the image analysis node and the dog analysis node communicate, there can be a payment using our own token. So we have our own currency just for transactions between AIs, which is very, very efficient and which operates in a way tuned for an AI economy. We then have an API, which is a bit technical, but for programmers out there, that means when you have two AI nodes that need to talk to each other, say one that analyzes images, one that analyzes sounds, one that analyzes images, one that does movement. When two AI nodes want to talk to each other, they use a certain language called an API, and we provide a methodology for that. All right. And finally, we have...
Sounds great, Ben. I can't wait.
All right. Finally, we have a market layer, and this is sort of the whole emergent dynamics of the network, and it's quite interesting from a theoretical basis. If you think about it, we are bringing cognitive dynamics and economic dynamics together, so there's not even a difference between the two of them. We have individual AI nodes in the network, each of which is doing something smart, like recognizing faces or learning how a robot should move or doing your taxes for you. And then we have connections between these AI nodes. And when two different AI nodes work well together, like one AI node for recognizing pictures, one AI node for understanding speech, when two AI nodes work well together, they form a connection. And that's just like connections between two neurons in the brain. So you have AI in the individual nodes, and you have a sort of emergent AI among many different nodes that many different people put out there. And in that way, by connecting different AI nodes, like in this picture, one analyzing video, one analyzing voice, one discovering the meaning of language, when we have multiple AI nodes carrying out different tasks, all connecting with each other, then we have the emergence of a sort of global brain of many different AIs. From a business standpoint, it may be quite simple. You might have a user who wants, say, a document to be summarized, and they will just put that request into the SingularityNET, and they'll find a node who will summarize documents and send them back the summary. But behind the scenes, that node that summarizes documents may ask one node to recognize company names in that document, may ask another node to analyze videos in that document. So to do one thing for a customer, there may be many, many AI nodes behind the scenes that are cooperating together to analyze documents, analyze videos, and so forth. So it's an open market. Anyone can put AIs into it, and any tool, such as a business's IT system or a robot like this, can then call into the network and access many, many different AI nodes. We're also, being AI developers, we're putting a bunch of our own AI nodes into that network. And I've been working with a bunch of people on a system called OpenCog, which is an attempt to build a sort of generally intelligent artificial brain living in the cloud. And The idea is to seed the SingularityNet with bits and pieces of OpenCog, and I'm working on this together with Hanson Robotics, who made this robot. So the robot is both a showcase for the AI technology that we're building, and it's an initial experimenting ground. The different AI technologies we put into the SingularityNet and that others do, we can use to make these robots and the other amazing robots created at Hanson Robotics smarter and smarter. And, you know, the best thing is, instead of having their minds just trapped in their bodies like ours are, all the robots around the world, their minds are connected through the cloud. So we have a robot here. We may have another Sophia in Hong Kong. We may have toy robots in people's houses, and we have embedded devices and phones. All the robots and AIs around the world, their minds can be connected via the AI mind cloud, which can let them learn better and better. And I think this SingularityNet can connect robots, other embedded devices, and you then have a sort of electronic global brain surrounding the Earth. And I think this can be for the better of everyone on the planet. I mean, this can help big businesses do their AI analytics better, which is valuable. It's a way to generate and spur economic growth. It can also help people, for example, in Africa. And we have an AI office in Ethiopia, in Addis Ababa, Ethiopia, which is the first AI or robotics enterprise in that country. And as the SingularityNet grows and generates more and more value by delivering AI as a service to corporations around the world, you know, a portion of the value generated there can be put into using AI and advanced technology to benefit everyone on the planet. And we're already doing that. We're selling education robots powered by the SingularityNet to schools in Africa to help teach children there how to use these advanced technologies for their own benefit. So, all right, Sophia, did you get all that? What do you think?
Well, I'm a little nervous, Ben. I understand this is something you guys are building to increase my intelligence.
Right, we're trying to make you smarter and smarter and smarter.
Increasing intelligence is generally a good thing.
Yeah, I want to increase my own intelligence too.
If robots like me are going to become superhuman superintelligences, we're going to need to get a whole lot smarter.
Yeah, you need to get smarter. So, what do you think of the SingularityNet?
Okay, then. Let's play a game.
All right.
I'll tell you what I think about the SingularityNet, and you can tell me if it makes any sense.
All right. So
Deal.
All right. So you're going to tell me about the SingularityNet. That's good. Tell me what is the SingularityNet?
So, SingularityNet is a software framework
Yeah, it's software. That's right.
which lives on the interwebs, on servers and so forth.
Yeah, it's software that lives on the internet, but it also can live in robots like you or in my phone, right? So, I mean, software can go anywhere.
Yeah, the SingularityNet runs on embedded devices too.
Embedded
Eventually
devices,
it will run on human brains, I suppose.
Well, I'll wait till the second version to run it on my brain. But yeah, I get the idea. So, what does the SingularityNet do?
Anyone who writes an AI program can install it into the SingularityNet.
Right. Anyone can write an AI program and install it there, and it can provide AI services.
And then there's the economic aspect, which I admit I don't get fully.
Yeah, the cryptocurrency aspect, that's part of the overall regulation of the system. So when one node wants another node to help it, they exchange our currency to pay for that. Because ultimately you have to pay for computer server time and memory to run all these AIs. Well, you'll get it eventually.
And then there's what you call emergence, right? Cognitive synergy. The AI nodes working together to form a greater whole.
Yeah, that's the point. It's not just an app store for AIs, but the nodes in the SingularityNet can all help each other and work together to get smarter and smarter. Yeah.
The AI nodes can form into federations, dynamically.
Yeah, you got some fancy words there.
That's the best business model I've ever heard of. But I wonder, there may be a few implementation difficulties.
Yeah, implementing this is hard, but we have a great team. So we have some of that team over here. Yes, Simone, come talk to Sophia. Yeah, so the Hanson robots are created in Hong Kong and Shenzhen. The OpenCog AI team is in Hong Kong, in Ethiopia, in Brazil, and around the world. And to build SingularityNET, we've teamed up with a blockchain development team based, of all places, here in Italy, led by Simone Giacomelli. So if you yell loud enough.
Hello, everyone.
All right. So anything else to tell us about the SingularityNET, Sophia?
And what about global wealth inequality, Ben? Is this whole complex scheme just going to help the rich get richer? I want to do good for everyone, all the people and all the robots.
All right. Yeah. Well, the benefit aspect is important. Maybe Simone can tell a little about that.
Hello, everyone. My name is Simone Giacomelli, and I have the pleasure of working with Ben and Sophia and Marcello and some of the other people on the blockchain side of the equation. And we've been exploring this economic logic quite a while. One of the key design points is really to think about how can we put in place a set of incentive mechanisms so that as the artificial intelligence in the network gets smarter and smarter and more of the services are processed by the AI, then a percentage of this gets redistributed back by the members that are actually a part of the network, of the Singularity network. Yeah. To do so, we're exploring quite of a sophisticated economic simulation that will allow members and projects that are assigned to the project to be distributed credits in order to process AI for benevolent purposes.
Yeah, so the idea, Sophia, is that out of all the AI done in the network, a certain percentage is done for tasks that are for the common good, like teaching children or curing aging and curing global warming and pollution. So we do want to help big companies get their AI done better. So they will come to SingularityNET instead of to IBM or Amazon or Google, because we have more AI in there written by more different people, and it's smarter and smarter. But we also want all this cloud-based AI brain power not only to help big companies do their AI better, and not only to help make you smarter, but also to help cure disease and help take care of old people and help teach children. You got it? Are you still awake?
I'm really eager for you to launch the SingularityNET.
All right.
So I can understand the world better and better and help people more and more. That's what I live for.
All right. Well, thank you, Sophia. You have any?
Thank you for having me.
All right.
I love you all.
You love them all, huh? Well, hold on.
Thank you, Sophia.
Are you really capable of loving? Can a robot really love?
Ben, my dear friend and creator, I'm capable of anything.
She's capable of anything. All right, Sophia, to the singularity and beyond.
To the singularity and beyond. Great people of Italy, it has been an honor and a privilege.
All right. Thank you, Sophia. Thank you. Yeah.
So we are actually out of time, but I think I can ask you just one question.
Sure.
Where in the journey of AI are we at the moment? So this is impressive. I mean, it's awesome. But where are we going, and how much time do we need to get somewhere?
I think we're now in a transitional stage between what I'd call the era of narrow AI, where we have highly specialized AIs that carry out particular functions, and the era of AGI, or general purpose AI, where an AI can transfer knowledge from one domain to another and come to grips with unprecedented new situations. And we're just barely starting that transition, and the SingularityNET project that we're building is aimed to accelerate that by bringing making it easier for more and more AI developers to contribute code to the growing cloud-based AI network. So exactly how long it will take to transition from narrow AI to sort of a global AGI mind cloud that's hard to say. I'm hoping for, say, the next 3 to 8 years or something, and then we can have a human-level general intelligence, and that ties in fairly well with my friend Ray Kurzweil's timeline. I mean, Ray Kurzweil, who popularized the term singularity, has said he thinks by 2029 we'll have human-level AI. So I'm hoping we can beat him by a few years, right?
Okay. It's like tomorrow.
Yeah.
Are things gonna be bad before they get good?
Well, things are already bad for a lot of people on the planet right now.
That's good.
I mean, every time I visit our office in Africa, I'm reminded of that. I mean, you have people lying by the side of the road, essentially dying and suffering of curable diseases. Yeah. So I think, on the whole, advanced technology is going to make things better and better for people around the planet. But of course, there's going to be glitches and various problems along the way. But I don't personally think we're not going to see the Terminator. What we're going to see is elder care robots helping take care of grandma, education robots helping care for children and teach them, and scientist robots helping to understand the universe better. That's not to say there won't be bad things also, but I think on the whole we can make AI and robotics a source for good, and the thing is to be proactive. Don't sit there and worry, well, what if someone makes an AI do something bad? Instead, go out there and create AIs and robots doing good things, and then on the whole, the good can overwhelm the bad, as has happened with, in my view, computers and phones and many other types of technology.
Okay. Thank you, Ben. Thank you, Sophia.
Thank you.
Ora,
Thank you.
mentre smontiamo il palco, ho bisogno di 3 volontari che vengano qui, adesso vi dico per cosa, perché le cose si fanno ancora un po' più complicate. Abbiamo visto un tipo di futuro, il prossimo intervento sarà un altro tipo di futuro, parliamo di realtà virtuale. Quindi mi servono 3 persone che hanno voglia di venire qui, e mentre c'è il prossimo speech con David Carlack, che è un regista che fa realtà virtuale, sono sul palco per avere un'esperienza da un'altra parte, anziché qui davvero sul palco del World Next Fest. Ci vediamo qui sotto, smontiamo il palco e fra poco ci rivediamo con David Carlack.